Good morning to doctor. My name is Jiang. Number matching is S72130. My topic I chosen is solar energy capture by a non-uniform panel, which is a real scenario. And the scenario is want us to calculate the total electrical power, which is the energy per unit time being generated by a rectangular solar panel that has non-uniform power density. So here is the contents. For the physical system, which is a rectangular solar photovoltaic panels, the quantity is to find the total electrical powers output in watts. So why we use double integral in here? Because the total power Q is derived from the non-uniform density, which Fxy over 2 the area R. The power inputs, the power output change at the xy. Since that the simple multiplications cannot work in here because Q is not equal to Fa, so the double integral will work by the mathematically to perform an infinite summations of tiny infinitesimal contributions area delta A, where the power density Fxy can be considered constants for that tiny space. There are a few variables that I want to identify, which we can model that the planar as region R in the plane xy. So let xy axis run along the edge of the planar. Xy equals to the coordinate cos the surface of the panels, and for the fxy is to describe the rate of the power generation at any specific point xy in the unit w per meter square. And then dA is the dx dy, R is the entire surface area, Q is the W is the total electrical power generated. So we can, since that we doesn't know before x equal to what, so we can put 0, then x, then A. So A is to total which, while the Y we can put B 0 and B the limits because we doesn't know. Then B equals to total length. So the physical principle used in here is the principle of the superposition. State that the total quantities, the total power Q of an extended object, the solar panel, is the sum of the corresponding quantity, like the power generated of all its individual parts. It can be used to apply to the continuous distribution. While this is applied through the Riemann sums, this theorem is used to eliminate all but one source of power within a network at a time. So the quantity used is the total electrical power output, which is measured in watts, while the quantity change across the region is the power density Fxy is not constant. So we can have to use an integral not just to calculate it area time density. So here in the calculation, firstly I will write Q equals to double integral Fxy dA. So since that I put A equals to 1 and B equals to 3m, so the limit of x and y can be found. So the equation U is limit 3010 150 minus 10x plus 1 dx dy. Then the w is the unit. So we can solve the inner integral first. So we get the 150 minus 10x minus 10y dx. Then I can find that is equals to 145 minus 10y. After that, we can use the equation to solve the outer integral. So the final answer will be 390 watts. Since that the ideal I found is 450 watts, so the loss is total 60 watt of the power deficit, which is a quantifiable measure of the inefficiency. By mapping the fxy function, we can know that which one is the at a higher density and which one at the lower density. So by using the calculations, we move from the approximations to the precise analytical solution. So this enable the engineers of the or the users to create more faithful digital twins of the real-world system, leading to a better predictive model for performance under varying situations. Then the improvement is this model can suggest that the density is lower as x and y to increase. So my reflection is the double integral can force us to view the solar panel as a continuous system instead of treating it as a black box of with a single efficiency number, so that we can know that every infinitesimal patch contribute to the final result, which vary to the function x and y. So this is very important for the system thinking. So for the sustainable problem solving, to get an accurate map of the energy generations and the loss across the panel, the double integral method allows for automations. This efficiency's improvement is the most suitable approach, as we can ensure that we get the maximum possible energy from the installed hardware and reduce the waste. So here is my reference. Thank you for your attention. Thank you. That's all.